Now I'm going to go through some octet exceptions, and that means that we're going to have central atoms that don't end up with an octet. In other words, they don't end up with 8 valence electrons. For the ones we're going to do, it's that they're going to have more than that, that the central atom is going to end up with 10 or 12, always in pairs, electrons. So let's just start. And sulfur is the one that's different, so it goes in the middle. I'll put my fluorine around on the sides. Okay, so first step, draw our skeleton, different in middle, all single bonds. At some point we need to decide how many electrons this should have. Sulfur is in the column that has 6 valence electrons, and fluorine has 7 valence electrons, so that's 28. So 4 times 7, 28, plus 6, so I've got 34 valence electrons. Okay, so 34. Well, I'm going to put those electrons on this molecule, starting with the outside. And fluorine is not like hydrogen. Hydrogen was happy with 2. Fluorine needs 8. Hydrogen, remember, hydrogen and helium only have 1 energy level, so they're happy with just 2. Fluorine, though, needs 8. So I put them all on. I put them on the outside first, and then I'm going to see how many valence electrons I've used up. So if I look around each fluorine, I'll have 8. I'll have 2, 4, 6, 8. So there's 8 there, 8 there, 8 there, and 8 there. So it's pretty easy to see that that all adds up to 32. But I have 34 electrons, so we haven't run into this before. We have too many. And so if I have some left over, then I'm going to put them on the central atom. And the way you do that is you just put them at an angle. You can put them at an angle in any of those places around there. It doesn't matter where you put them. Anyway, so that's what it looks like when you have an octet. You're going to have to break that rule about keeping them all on the square. And what I mean by breaking the octet is, if you look, how many valence electrons does sulfur have now? It has all of those. So that's 10. That sulfur has 10. Of course, just reviewing, this fluorine has 1, 2, 3, 4, 5, 6, 7, 8. So it has 8. Okay, and now that you kind of have the idea with this, I think you're ready to do a few without me doing them right away. So why don't you pause your video, please, and see what you can do with these two. It will help you if you're trying some of these as I go. So go ahead and pause. Okay, let's go ahead and see what you got. So we're still on the octet exceptions page, so maybe that was a little bit of a clue. We're going to start with a central atom, different in the middle, and then, I was going to put on my fluorines on the outside, and I see that I have 5. So I have 5 surrounding atoms, so I'll just do this. It tells me right away I'm going to have an octet exception for phosphorus. So I'll put my fluorines around like this. And let's see, so phosphorus, how many valence electrons does it normally have? It normally has 5. It's on the column from the periodic table. Fluorine has 7, so 35 plus 5, that's 40 valence electrons this normally has. So I've got to put a lot more on. How many do I have on there now? I have 10. So I'm just going to start putting them on these fluorines because I know fluorine needs 8. So I'm just going to put them all on and see where I'm at. Give fluorine its octet. Okay, and then after doing the fluorines, if I count now, I have 8 times 5. That's 40. So that compound is good. It has all octets. Phosphorus has an exception of an extra 2, but that's okay. Okay, let's do another one. So on this one's interesting because this is a noble gas, xenon, and some of the bigger noble gas atoms do form compounds, and we like to use them in examples because they have interesting geometries, which we're going to see a little later. So I put xenon in the middle, and my chlorines on the outside. Xenon normally has 8, chlorine 7, so 4 times 7, 28, plus 8. So I should have 36 valence electrons for this. Okay, so I'll start putting them on the outside again. Chlorine needs 8. Okay, and then all the chlorines have their octet. So I'll count and see where I'm at. I have 8, 8, 8, 8. That's 32. I have 4 more electrons to put on. So when you have extra electrons, you just put them up here beside, kind of at an angle, but you want to put them in pairs. So I'm not going to put them together. I'm going to put there and there. It doesn't matter which corners you choose, as long as they're not all together. And that's it. That's our last octet exception. Again, you guys, if you're having issues with this and it's not quite clicking, try the lab videos, and it really helps you if you attempt each one before I go through it, because it's really easy to see, to follow along if I'm doing it, but it's not the same as doing it yourself. So anyway,